The definition and need. An algorithm is a step-by-step procedure for solving a particular problem. The major purpose is to develop an efficient algorithm for processing of our data. The efficiency of algorithm depends upon time and space it uses. The complexity of algorithm is a function which gives the running time or the space in terms of input size. So we need to study algorithms in order to understand data structures in a better way. We need algorithms to understand what time and what space that particular algorithm will take to implement any data structure. And we should have minimum time and space to implement any algorithm in order to have the greater efficiency. Now let's start with complexity and time-space trade-off. Each of our algorithm will involve a particular data structure. The choice of data structure will depend on many things, including the data and the frequency with which the data operations are applied. Sometimes the choice of data structure involves a time-space trade-off. By increasing the amount of space for storing the data, one may be able to reduce the time needed for processing the data or vice versa. See, always we have to take into the consideration time and space if we want efficiency. If the time is increased, then we should take care of space. It should be decreased accordingly. If space is increased, then we should take care of time. It must be decreased accordingly. So that at the last we could have a better result. And we may not always be able to use the most efficient algorithm. It is not practically possible to have an efficient algorithm every time, but we may always strive to use efficient algorithm. So we must take into consideration time and space. Now, let's look into it in a detail with the help of example. You might have heard about linear search. Linear search means searching an element in a list with a linear fashion. If we want to search any element or any name or anything in a given list, then what we should do? The common phenomena is we will compare the one which we want to search with all which are available in the list right from the beginning. If it resembles, we will say yes, the element or name or whatever data item is found. If it doesn't, then we will compare it with the next element present in the list and so on. So this is one of the way through which we can search any element, and this searching mechanism is called as linear search. So for example, consider employee details file in which each record contains, among other data, the name and the telephone number of its employee. Suppose we are given with the name of employee and we want to find his or her telephone number. One way to do this is in a linear fashion, as I told you. What we will do? We will search each record one at a time until finding the given name and hence corresponding telephone number. The time required to execute this mechanism or this algorithm where we are comparing each record with the one which we want to search will take some time, and it will be proportional to the number of comparisons. So the average number of comparison for a file with n records will be equal to n by 2. That is the complexity of linear search. So algorithm's complexity using linear search will be n by 2. C of n is equals to n by 2. This is a representation technique. This algorithm takes large amount of time, as we saw. If we are searching through the list consisting of thousands of names, as in telephone books, if we want to search any element which is having from a list which is having various records, thousands of records, then it would be very difficult for us to search it, and it will take more time. Now the other technique available is binary search. What binary search say? Basically, binary search applies on the records or on the list which is already sorted. Means there must not be any repetitive element in the list, and thus it can be made efficient. So if we have records as sorted file, then we can use efficient algorithm called as binary search. Binary search, we will compare the given name with the name in the middle of the list and tells which half of the list contains name, and compare the name with the name of the middle of the correct half to determine which quarter of the list contains the name. See, if you are having a list of n elements, then what will you do? You will first compare your element which you want to search with the middle element, means the element which is present in the middle position of a given list. If it is that element, then it is fine. And if it is not, then we will see the elements position. If it is less than the uh, middle ones, then you will get the element in 0 to n by 2, means in first half. If it is greater, then in second half you will find the element. Thus, you have reduced the whole list into half. Then again you will have to compare that element with the element which is present in half of that list at the middle position. So again that half list will converted into two quarters, and in one quarter you will find the element, and so on you will go on until you find the element. This is called as binary search. So continue the process until finding the name in the list, and thus the complexity will be log n to the base 2, which is very minimal as compared to the linear search. So the major drawback of this algorithm is that it assumes that the element the element will be compared from the middle position, and the person has to access the element which is at the middle position directly. It is one of the major drawback of binary search. Now let's understand the time and space trade-off for this algorithm. Suppose a file of record contains name, social security number, and much additional information among its fields. Sorting the file alphabetically and using binary search is a very efficient way to find the record for a given name, as we have understood it before. Now, on the other hand, suppose we are given only with the social security number of a person, then we have to do a linear search for the record, which is extremely time cost consuming for very large number of records. So one way to solve that problem is to have another field, which is sorted numerically according to social security number. This, however, would double the space required for storing the data. And another way to have the main file sorted numerically by social security number, and to have an auxiliary array which only have two columns, the first column containing an alphabetical list of the names and the second column containing the pointers which gives the location of the corresponding records in the main file. This is the way of solving the problem that is used frequently, since additional space containing only two columns is minimal for the amount of extra information it provides. Thus, we can conclude that time and cost must be minimal.